Innovators recognize that renewable energy is not only about PPAs, power generation, shareholder return, and grid stability. In fact, its role on the global stage is just so much bigger. Renewable growth brings confidence, security, economic stability, and an ability to fulfill basic human needs, regardless of jurisdiction or geography. Fully realizing this potential comes not from analytical thinking, but rather from thinking holistically and synthetically. And to achieve this, innovators realize that effective and impactful decision making, timed correctly, is critical. In today's webinar, we will again demonstrate the power of holistic thinking, this time, though, applied to renewable asset development. Despite asset development being arguably the most critical phase in the asset lifecycle, the continued lack of investment in terms of time, human resources, and cost is a constant pressure. After all, it is the development phase that answers critical questions such as availability of natural resources like the sun and the wind, or even the wave power, power quality issues, location of resources, barriers to information provision and creation, costs, both direct, indirect, as well as unforeseen, and indeed the tons of resources required to execute a renewable asset. Whilst this is a source of frustration amongst many development organizations, often resulting in mechanistic project development and ambitious forecasts, there are some organizations that are really digging deep and bucking the trend. They use front-end loaded decision-making to great effect. One such organization is Cubico Sustainable Investments, and their global development function, is led by Matt Boss. Having worked in the sector since 2004, Matt is one of the most passionate people we've worked with. His passion for the transition to renewables is obvious from the minute you meet him. After 4 years with BP Alternative Energy, leading BP's entry into the Indian wind market, Matt moved to Mainstream Renewable Power. 5 years of his time at Mainstream was based in Chicago, developing wind projects in the Midwest and ultimately leading the US and Canadian development teams as country manager. Matt then joined Cubico in 2016 as a technical director with the mandate to create a technical capability for the company. He then moved into the head of Northern Europe role, where he was responsible for Cubico's 250 megawatt wind and PV operating assets in the UK and establishing a development JV with Peel NRE before becoming the global head of development in July 2022. Cubico is an international renewables IPP, owned jointly by Ontario Teachers Pension Plan and PSP Investments, with 3 gigawatts of wind, PV, and CSP plants in operation across 12 countries in Europe, the Americas, as well as Australia. The organization is expanding its development activities in all markets as a means to further its long-term build and hold strategy. I'm delighted to introduce Matt, who will now spend the next 40 minutes taking us through his riveting presentation, where we're going to be exploring the opportunities that lie within the development phase. May I ask that if you do have any questions, please register them in the Q&A function. We will then be able to prioritize or organize them and address them at the end of Matt's presentation. During the presentation, there will be polls that we will be presenting to you. Please take your time to read through them and answer them as truthfully as possible. It gives us a real understanding of what is actually going on out there on the ground. Once again, delighted to have you on board. And Matt, over to you.
Thanks very much, Rakesh, and many thanks for the kind words as well, both on my behalf and Cubico. Good morning, or good afternoon, good evening, wherever people are. I'm just sharing my presentation here, so hopefully it's appearing on your screens. Okay, Rakesh, you seen that?
Yes, I am.
Great stuff. Okay, so let's get into it then. So I've been tasked with talking about how we can use project development as the springboard to value creation. And so yeah, over the next half an hour, 40 minutes or so, I'm going to do that firstly with a little bit of introduction, which Rakesh has kindly given me my own springboard for, before defining development a little bit with regard to renewable energy, but then getting into the very specifics around how we do that. So life cycle governance and the renewable stage gate process are the tools by which we use to integrate our development activities with the long-term value creation that we aspire to within Cubico for our projects as a whole. So that is how we get at the holistic value, and I'm going to talk through that as we go through the presentation. But I'm going to wrap up with some case studies that hopefully bring what I'm talking about to life. So you will see it very much from a conceptual standpoint to start with, but then we'll dig into, if you like, a successful case study and a case study maybe where we could have done things a little bit better. Rakesh already mentioned something about what Cubico does, so I won't dwell on this slide. But just to say, you know, we come at this from very much a perspective of being an asset manager ourselves. You know, we have a lot of projects in operation. We started really as an asset acquirer and operator, and so we're really interested in long-term value. We're not a fund. We're owned by pension funds who are seeking to run us as an IPP, and so we look for every decision we make to maximise the long-term value of our assets. And so as we've stepped into development over the last couple of years, and as we're going to increasingly ramp up our development efforts over the next few years, the way that we look at development is very much with an eye to creating and then ultimately realising that long-term value for all of our projects. And I think that's a really important point. That's probably the key point about Cubico that I'd like you to understand. You know, we're not a develop and flip. We're very much looking at this from the long-term perspective. So let's get into the details then. So defining development, just so that we're all on the same page, how do we actually define development as a whole? So life would be very easy if we could turn up and find an empty site like the field on the left-hand side there and say, right, great, let's put a PV project in this field and we build a project. I think everybody on this call knows it's not as easy as that. So for the purposes of this call, I'm really defining development as, you know, everything that happens in between that. So what happens from the moment that we say this field could have a project in it to the moment where we can actually build and construct that project. You know, there's lots of things that we need to know, and I don't need to dig into these in detail, but I'm just putting them up on the screen. They vary in the disciplines, they vary in the kind of things that you need to be looking at, from technical, engineering, permitting, land control, project finance. You know, you're requiring the inputs from many different people. You need to interact with stakeholders and government entities across a range of different departments and different just sectors of the economy, I guess. From you can be employing people who are watching birds one day, and then you can be testing the groundwater conditions of the site the next day. Completely different skill sets, a very wide range of things to do. So how do we go about this, and what exactly is happening within this development phase? So I think you won't be surprised to hear that the answer to a lot of this is project management, right? So project management is absolutely critical. If we're going to get from A to B and have a project that we can actually build, we're going to need to pull in all of those work streams that I talked about, all of those different people that are going to contribute to your project. Some will be within your own organization. So, you know, you might have people who are looking at the energy yield of the potential site. But equally, you know, those people that are monitoring birds, they're probably going to be third-party contractors. So a project manager needs to be thinking about, how do I get this project from A to B? How do I break it down into manageable chunks? How am I going to manage the team that is then going to ultimately create this project that I can then go and build? So, you know, when do I need to employ somebody to look at the birds? When do I need to submit my grid application? Is it worth putting down £100,000 to secure the grid at this stage? Do I know that it's safe to do so? So fundamentally, project management requires that you've got a very clear work breakdown structure. You understand what your project is aiming to achieve. You've got very clear objectives. Hopefully you've got a project charter in place, which gives you the scope and the ability to run your project. It gives you the authority to run your project with very clear mandate from the project sponsor. But you need to control that project through schedule, through budget, and through managing your risks. And so you need to use controls all the way through the process to get there. So project management is absolutely critical, and you're going to be harnessing the skills of all of those different teams and doing it on a regular basis. And the project manager has to drive the project from A to B and get it over the finish line. But the point I want to make today is that that's not actually enough on its own. So we need project management. But let's face it, if you can get a project from the point at which you say it's physically possible, it's technically possible, you're not actually sure that you can then go and build it because you need financing to do that. And many technically feasible projects are ultimately rejected. We are constantly whittling our portfolio down. We whittle our pipeline down to find the projects that are actually going to be the ones that we can ultimately invest in. At the end of the day, if you're a renewables project and you get all the way through your development phase, you need then to find an offtake agreement or some kind of way of selling the power and the other attributes from your project that will make it economic. But you also need to win investment, and whether that's from Cubico or whether that's from somebody else, it's a really tough and competitive market out there at the moment from investment. So how bankable your project is, how economically feasible it is, all is going to come into the mix and will ultimately determine whether your project makes it or not. In my experience, and not just Cubico, but this is going back through my mainstream and BP days, there are many projects that I've come across which have been taken all the way through a 2 or 3 year development cycle and ultimately been proven not to be possible to build. So you really need to begin with the end in mind and make sure that that project is going to be viable. So how do we do that? We need to take into account some of these other elements that you can see on the bottom of the screen there. So we need to be looking for ways to create value through the project. And the case studies will illustrate this quite neatly. Not every project in the same field is the same project. So, how many turbines am I going to use if it's a wind project? Have I got the right turbine? Have I got the right layout? Am I appropriately using all of the different inputs that I've received through the development phase to optimize my design, squeeze the most value out of this? Am I partnering with my ultimate suppliers to ensure that I've looked at every possible angle to enhance the yield? If it's a PV project, should I be looking at bifacial modules? Should I be looking at trackers? There are many different ways that you can design and engineer your project to squeeze as much value out of it as you possibly can. At the same time, you're going to be learning about your project during this phase. We're not talking a couple of weeks of due diligence or even a couple of months. You're talking potentially 2, 3, 4, 5 years of development effort, working with this site, talking to many stakeholders, learning about it, receiving reports, entering into agreements. All of them will give you information that you should be taking in, absorbing, working out where your potential risks arise, and then finding out whether there are things that you can do about them. If you've got a fatal flaw, you really need to try and kill that project quickly. Don't throw good money after bad. It's very tempting, and all project managers out there will tell you that projects become your babies, and it's very difficult to make the hard decisions sometimes when you need to. But if you can't eliminate those risks or design them out, then that's what you need to do. But often a risk will ultimately become an opportunity, and you can say, well, if I can't do it this way, then maybe there's something else that I can do. Can I switch it from being a wind project to a PV project, for example, if you've got a good grid connection, but maybe you've got radar issues that tell you can't put turbines in. So there are many ways to look at projects from different angles, and looking at it through the risk reduction lens is very important. And then the final piece, and all three of these tie together very closely, how can I reduce the levelized cost of energy that comes from my project? And ultimately, if you're going to win that offtake agreement, then you need to have the lowest cost of power possible, because that's what's going to tell you whether you can build your projects or not. I have a cost of energy that's coming from the plant, which is driven by the capex and the yield largely, with O&M inputs as well, but primarily down to the cost that you need to install that plant. If you can reduce that as far as possible, it puts you in the best possible position to be able to win your offtake agreement when the time comes, and it tells you that you can compete against other projects, because ultimately you haven't got to win some kind of absolute contest against the market. At the end of the day, you're competing for contracts against other projects. So how relatively competitive is my LCOE compared to other people's? So these are the angles that we need to be looking at. And we need to be considering this alongside the technical project management that you're conducting throughout the process. So how do we best bring all of these elements together and manage project management in such a way that we're considering these elements and making good decisions as we go through the project? And this is where the stage gate comes in. So the stage gate model is actually something that was designed. It wasn't originally designed for renewables projects, or in fact, or even large capital projects in energy in general. It comes from the world of project development and product innovations. It's credited to Robert G. Cooper from the 1980s, and he was looking at product innovations from a number of different angles. And the concepts are very similar to what we do now in developing new energy projects. You start with a funnel of many different alternatives and options, and you consistently whittle that funnel and pipeline of projects and opportunities down through a very disciplined stage gate approach. And we're going to just run a little video where Robert Cooper talks about a stage gate in a nutshell. So Khalida, maybe you could run the video.
Well, stage gate is pretty simple in concept. It's basically breaking a large project into a series of stages with gates between them. You do some work, you gather some information, you assess the information, you make a decision. Do I continue? Do I continue to invest? Do I put more money in the game? And then you move to the next phase. So it's really a way of taking any project, not just a new product project, but any project that is done over time, and breaking it into a series of manageable bite-sized chunks with decision points along the way. Am I still in the game? Do I still invest? So it's a very sensible way of running any project. As we talked about, one way of mitigating risk. But if you think about it, it's the way just about any significant project, whether you're constructing a building or doing process research or what have you, should be run. And that's the stage gate process.
What was the origin? How did
That's great. Thanks, Khalida. We'll just move back to the presentation. And so, yes, so just in summary there, what Dr. Cooper was saying was exactly that. So you start off in one gate because you're going to run through multiple gates, as I'll show you in a moment. You start off with a gate. You go through the process, you do your work, you gather your information, you assess that information, and then you make a decision. And what basis you make that decision on is very clearly defined. And then, can I move through the next gate? And the question is, how disciplined are you about making that decision to move through that next gate? So let's now apply that to renewables. And this is an approach that I've seen used not just in Cubico. We had it as something similar in Mainstream, and we had something similar in BP as well. So this idea of a stage gate process hopefully is familiar actually to people that are on the call. It may not be new, but we're talking about what the concepts are behind it. So it's widely adopted across renewables, across energy, across infrastructure projects in general. So through the feasibility stage, this is really before you've decided that you've got a feasible project. You're screening that project, you're looking at the economic viability, you want to work out if you've got any potential fatal flaws. Hopefully it never even makes it through that first gate if you have. But the key question is, do I want to bring this project into my portfolio? I've got limited resources, I've got limited time. I want to make sure I'm backing the best projects, the ones that I think, even at this very early stage, look like they might be competitive in terms of LCOE, and therefore will be well placed to win a contract at the end of it. So then, hopefully, if your project moves through from the feasibility into development stage, you've defined your project, you've got a sponsor, you've got very clear objectives, you understand what you're trying to achieve through it, and you've got a budget and a plan to run the project through to the next stage gate. So in this point, we're into the development phase proper, and this is where you're going to sit for probably 2 or 3 years in wind and PV, maybe longer, given current permitting processes. Although I've got my fingers crossed that governments around the world are looking for ways to speed up permitting, as we all know we need to. So you're going to spend a bit of time in development, and a big theme of what I'm trying to say today is use that time to the best of your ability to make the most of this project opportunity. This is not just about ticking off a series of boxes to get you through the next stage gate or to get a project to the end of its run. This is about making sure from day one that you have created the most competitive project that has got maximum yield for minimum cost, has dealt adequately with all of the risks, has foreseen issues, and is able to deal with them early so that when you come to contract, you can handle those risks and appropriately manage them and split them between yourselves and your contractors. And ultimately, it's to address the question, do we want to invest in this project? You didn't know that much about it when you went through the feasibility gate. Well, by the end of development, you're going to have a pretty well-rounded project, and you need to have a good answer to the question, why are we investing in this? Is it the right project for us? And obviously, critically, before you move through the next gate, is it ready to build? So then we get into the pre-construction phase, which is typically much shorter. You've made an investment decision at the end of development. So you're saying, yes, this project is competitive. We know we can do this. Pre-construction is all about getting ready for execution. So you're assembling your project execution team by that point. The construction project manager should be appointed during the pre-construction phase. You're going to finalize your plans, and the contracts really should be just rolling out on a basis of, okay, we've had a tender package, we've worked out what our risks are, we know why we want to do this project and how we're going to make the most of it. So then we're going to close contracts on that basis. And ultimately, pre-construction will end with financial close and issuing notice to proceed. Then you move into construction, and I won't dwell too much on construction and operations because we're all about development in this conversation. But construction is about execution. And what I'll say on behalf of my construction colleagues is execution is an awful lot easier if you've got development and pre-construction right. So it should be, construction is never straightforward, and there are always things that will be thrown up to test you. But if you've got everything else right, it's an awful lot easier, and your construction project manager will thank you if you've got a very well documented plan and it is considered all angles, and that you're aware of any risks that you're running as you go into construction. Construction has its own stage gate, of course. When you get to the end of the construction period, you reach COD. You're looking towards a takeover by the asset manager. The asset manager should be engaged before the end of construction and help working towards through things like commissioning and the COD process itself. Snagging lists will be developed, and so there's a very crucial takeover at this point. When you move through that gate, the asset manager is taking on responsibility into operations, and hopefully that'll work very closely and carefully with the construction team in order to do so. And then obviously operations itself, you're going to have many mini projects as you go through the operational phase. You've got overhauls and all the rest of it. But I won't, as I say, I won't dwell on that as we're talking more development here. But hopefully that puts development in context with the overall life cycle of projects and explains how we apply the stage gate model to renewables specifically.
So Matt, it's at this point where we'll ask everybody whether the stage gate model is something that's used within their respective businesses. So Halida, do you want to run the first poll, please?
Okay, just while people are thinking about that and answering to that poll, I'll move on to the next slide, because we're going to dig a little bit further into the stage gate model on renewables here, and really get into the meat of what we're trying to achieve with this presentation this morning. So I want to dig more into this development and pre-construction area. So we talked about feasibility, and we know we're heading into construction. But as you can see from the graph towards the top end of the graphic here, the development phase is really the moment when we're reducing risk in a project significantly. We're looking to de-risk projects throughout the development process, but certainly from when a project moves into development to when it moves into construction, that's the significant period of de-risking. And again, your construction manager will thank you for having de-risked the project as much as possible by the time it moves through that last gate. And it will enable you to achieve the lowest possible cost of capital and probably reduce capex as well if you can do so. So how do you do it? I mean, you're going to be acquiring land. You're going to be analysing the resource on site. So, obvious things that you can do are things like, well, I'm going to make sure I've got bankable leases for my land, or even acquire the land itself. You're going to measure the wind resource if you've got a wind project. You might even put pyranometers on site. Sometimes you do, sometimes you don't for PV. But if you're looking at bifacial or trackers, or if you've got a large site, I think more and more we're seeing that having pyranometers can reduce risk and give you more clarity around exactly what your PV resource looks like. You're going to be working with the grid. So you've usually got decisions that you can make with the grid company. Am I going to go contestable or non-contestable? Shall I reduce my capacity a little bit so that I can get a little bit better bang for my buck in terms of the cost that I've got to connect to the grid? Or maybe it makes sense to maximise the size of that project. This will be done in tandem with the land and the resource. So you're going to have to compare the technical there with the economic. You might be starting to look at who might buy this power. Hopefully this is something that you've already considered in feasibility. You might have somebody nearby who's a natural off-taker for the power, or you might be looking for a government auction or a CFD contract. If you're in the US, you might be looking at tax equity. So having ideas as to where you're going to be able to ultimately originate those contracts is going to be important, and building relationships with the ultimate off-takers, and maybe even designing the project to suit those off-takers could ultimately add value to your PPA. When you go through environmental studies, sometimes these things are seen as a risk and they can be a concern. If you understand exactly where that bat is roosting, then you can early on put exclusion zones around the bat roosting areas, and then decide to reorganize your layout accordingly. You might even go after different land if you've got a good early idea of where the environmental studies are leading you. And then finally, and crucially, your financial model and understanding project finance terms. At Cubico, and we did the same when I was at Mainstream as well, we will have a financial model as a project is moving out of the feasibility stage. So we want to understand, obviously you don't have all of the numbers at this stage. Obviously there's a lot of uncertainty and you can't finalize things, but you should have an idea of what your project is going to deliver, and you should have an idea of what you need it to deliver, and it should direct some of your development activities if you can understand the sensitivities in your financial model from an early stage and start to work with them. And having a good idea of what project finance terms you're likely to get if you're expecting to use project finance will also help, because that can skew your sensitivities if you're not careful. The really key concept here is this idea of front-end loading, and I'm already talking about some of these front-end loading ideas as I'm speaking now. But the concept here is a central concept for the presentation this morning, is that the more work you do early on, the better you understand your risks early on, and the better you can design your project early on, the more problems that you can reduce for later down the line. So as you get into pre-construction, you're going to get into detailed design and engineering. It really helps if you've thought about this before you get to that point. So if it's a PV project, how flat is my land? Am I going to have to grade this site? Have I got drainage issues? Because one of the downsides of a lovely flat PV site is often you've got really bad drainage issues, particularly if the farmer has kind of led you in that direction in the first place by saying, well, of all my land, that's the field that I'm going to let you use for PV. We often find that that drainage issues are a problem on PV projects, and I'm going to come to that in one of the case studies that we address soon. So how do you consider that when you look at it through your land acquisition process, and you consider it when you're considering the environmental constraints as well? These things can actually take out risks before they become an issue and before you have the significant cost of trying to put in complex drainage or whatever it might be. Similar with your equipment agreements in general. For wind projects, I think it's probably the most obvious example. If you understand your shear factor for a wind site, so that is how much more your wind resource increases as you get higher towards the tip height. That's going to determine what best turbine equipment you can use on site. You need to be thinking about the noise of your turbines. You need to be thinking about whether a larger rotor might help you potentially in a lower wind site. So equipment selection and how you manage the layout, because a larger rotor leads to needing wider spacing, which has a knock-on effect to your land and potentially your environmental studies. You can see how thinking about all of these things early on and having initial iterations of your design ultimately play into having a much better idea and a much better project when you get into this pre-construction stage. And I'd really counsel against waiting until you get to that point and starting the turbine supply agreements and then working with a layout that the turbine manufacturer puts in front of you, because it's not likely to be optimal from your perspective as a long-term owner or operator, or if you're intending to sell to a long-term owner or operator. I won't run through the other issues on pre-construction. I think I wanted to focus on the front-end engineering and design, so that's why I'm sort of majoring on those first couple of items there. Do we have another poll at this point, Rakesh?
Absolutely. So we are very interested in how widely front-end loaded decision-making is used to support the feed process within any of the development activities you do. So we'd really appreciate your response to the poll that's on screen in front of you right now.
Great stuff. Okay, I'm going to keep going because the polls are coming thick and fast, I think, at this stage of the presentation. So I'm going to move into the first of two case studies. And as I said earlier on, the first case study is an example of how we used the stage gate process and front-end loading to make some good decisions and improve a project as it went through a stage gate. But I've also got an example of where things could have gone better, because I think it's useful to have both perspectives. So with this first case study, and you're going to be asked, the next poll is what stage is this project in? So I'll sort of ask that question now, and maybe the poll could come up as we go through this as well. So the first case study is around a wind project. So we start off, we think we've got a 36% capacity factor. We've got plenty of wind data, and we've got a turbine which is permitted, and so that capacity factor is specific to a layout and a turbine that we've already designed. Land is already leased for that permitted layout, so that's great, and we've got permits in place with the local permitting authority. On the interconnection side, the capacity is confirmed for the grid, just waiting for a final design study before we can execute an interconnection agreement. On the PPA side, we know we've got some auctions expected, but we haven't got any details confirmed on that yet. And engineering, we've done some basic geotech. It looks like we might have a bit of a high water table on this site, but as far as the basic geotech went, we've got some preliminary turbine and cable layout, and it kind of looks like it's going to work. And on the construction side, the access has been reviewed, and we know that neighbouring wind farms have been successfully constructed. So it probably looks like it's feasible there. So what stage are we in? Has that poll already gone up? Have people had a chance to?
Yeah, we've had 5 responses so far, Matt.
Excellent.
We've now got 6 responses. 16% say feasibility, 50% say development, and 33% say pre-construction.
Excellent. Okay, we've got a good spread there, and I think the point here is that the and one of the key questions to answer here is, some activities seem quite mature and other activities seem a little bit earlier on. So I can understand why, some people might argue, well, we're in feasibility because maybe the engineering doesn't look like it's been particularly, well developed. You only got basic geotech, whereas you've already been all the way through the permitting process. So you can make arguments in many different ways. We were trying to ask ourselves, okay, what stage are we really in here? And where do we need to get to? How are we going to make a disciplined and decisive decision to go through a specific stage gate? And how do we reduce the levelized cost of energy so that we can be as competitive as possible? So the answer that we came to was we're in the development stage. Most activities were fairly developed and mature. The engineering, we felt, although it was relatively basic when we took the project on, we felt that it could be brought up to a level that would take us through the development stage, but it was certainly past feasibility. It didn't need to go back through the feasibility stage. There was enough to tell us that this site could be built, and we didn't have any fatal flaws on that front. So we're in development stage, but this project has been a little bit unloved in some areas, and so there's lots that can be done to increase the value of it. So for example, on the yield side, you can install more met masts. You can have a goal to increase your P90, P50 ratio to make the project more bankable and to squeeze more yield out of it. Improve the layout, get a better turbine, reduce weight losses, it all helps. On the land side, let's get more land. Let's work out what our permitting constraints are, what our environmental constraints are. And with a new layout, sell that concept to the landowners such that new landowners come on board and say, well, actually, if I know I'm going to get a turbine, then I might well be willing to go on to this. With more land, you can spread out those turbines. It gives you many more options to add value. Re-permitting for the new turbine model is critical. Understanding your risks through things like noise and shadow flicker and also the burn and bat studies is also really important. So you end up with a stronger project by having a better understanding of that, the site, where your limitations are, and being able to tell a stronger story to the permitting authority, as well as actually giving yourself a much better and stronger footprint to use for your layout. On the interconnection side, I mentioned contestable works. Typically, where you can do things on a contestable basis, you should. It's not a 100% rule, but generally speaking, you can often contract things for cheaper than the utility will do work for. But if you also do things like load flow analyses, which you can do independently, it will give you a clue as to how much curtailment you're likely to hit when you're further down the road and you're into operations. Understanding that could actually produce a fatal flaw at a late stage. So you really want to understand what's the risk of curtailment issues early on where you possibly can. So then the offtake, as I say, this is critical in terms of economic viability. You're going to reduce the LCOE as far as you possibly can. This enables you to be more competitive when you come to your PPA. So let's get out there, start originating, start marketing the project, work out all the different ways to achieve a PPA. But then with all of the information that you're getting, how can we improve the engineering? Even before we move through the development into pre-construction, how do we create the tender pack that we're going to want to our EPC contractor to respond to? So we can resite the substation. Let's get closer to the connection point. Let's reduce the cost of the high voltage infrastructure that we need to build. Let's reduce electrical losses by improving the layout of the cables. Okay, I've got a battery signal there. Hopefully we're not going to run out of battery. And then, ground investigations. I mentioned that we might have a high water table, so improving the level of understanding around ground investigations can help to reduce the BOP risk that we run as well. So you can push BOP risk onto the contractor. More information you give them, the lower cost they will charge you to accept that risk. So through doing all of this, in this particular example, we took a 120 megawatt wind project, turned it into a 110 megawatt wind project, which sounds like a trade down, right? But with a much improved capacity factor and with everything else now being viable, and the value of the project overall shot up from $6 million to $16 million. It took a $2 million spend over 18 months, but that was a very well spent $2 million, and it got the project to the point where it could move through that development gate. It was highly constructible, and construction financing was very easy to achieve at that stage. So this is what I'm talking about, this sort of holistic approach to development, understanding all of the risks that you're going to encounter that will ultimately help you through construction and operations and increase the value of the project as well. But what happens if we don't get it right? So here's a project, and this is a project that's in operations now. This is a project that we're very familiar with in Cubico. So it's an operational project with significant drainage issues. It has standing water across the site, and you can trace the problems back through to the development stage. It caused problems through construction because obviously when you've got drainage issues, it takes longer to construct. You run into difficulties, contractual difficulties with contractors. Maybe you've got insurance claims to make, particularly when you've got delays and additional costs that arise through construction. But obviously then your problems are long term, and this is where it really drives us up the wall at Cubico. If we enter operational challenges, as I mentioned before, we're trying to increase long-term value of the project. And so when we have operational challenges, including meeting availability due to our inability to access the plant, it causes a long-term headache. It causes long-term project returns to be reduced. It also gives you safety hazards, which are perfectly avoidable. We need emergency vehicles to be able to access. With all of this water, vegetation can rise very quickly, but you can't access to cut it back. And so that gives you a fire risk when then things dry out. And also you're potentially creating habitat for dangerous fauna like snakes and alligators. This is not a UK site. So what went wrong, and how could you have avoided this through the development process? So in this case study, first, in feasibility, the issue can be identified. And I think in this case, actually, it was identified. We understood that there was a drainage issue. This was actually a rice field, and it was very used to being flooded for growing rice and then drained. So the previous use had worked out how to manage drainage on this site and had a system for doing so. Unfortunately, we didn't use the development phase to really understand how that worked, work with the site, learn as much as we possibly could to do it. And instead, when the EPC contractor came in, the site was levelled, a sheet flow approach to drainage was taken, and all of the original drainage systems were removed, and we kind of started again. Unfortunately, this caused significant problems, particularly when roads were built on the site which were slightly above the sheet flow, and so they caused effectively sort of levees in between the different sections of the site, which actually prevented drainage rather than facilitating it. It was also a very, very large site, and so as far as sheet flow is concerned, as a concept and an approach for drainage, it probably wasn't the best way to look at things. So during the development phase, you've got time. I mentioned it before, you're potentially in this phase for 2, 3, 4, 5 years. Use that time, understand the site, talk to stakeholders, get studies done, develop information so that when you come to tender for the EPC contract, you've actually got a really clear idea. You can pass information on to the EPC contractor and you can say, right, you understand about this site because we understand about this site. I now want you to take these risks and ensure that your design responds to these risks. And you can have an appropriate sharing of risk with the EPC contractor. Always, always, always maintaining that focus on the long-term project returns and recognizing that if you take a shortcut, such as not looking for a sort of 20K civil engineering site, civil engineering study during your development phase, you could well run into issues at the contracting phase. That is my final slide, and I got there just in time as my battery died on my laptop, Rakesh. So I'm pleased that the timing worked out just well. Did you have another poll just at the end of the presentation there?
Yeah, that will come a little later on, but we do have some questions that are lined up in the Q&A section, Matt. But before we go into those questions, that was an excellent rundown and run through of how you utilize key management tools such as stage gate model and front-end loaded decision making to drive performance. And this is a body of knowledge that we're looking to grow within the renewable industry globally, so people realize the importance of making the right decisions as early as possible within the project. And you've demonstrated the role that development has to play in that process very, very well. So well done. Well done. We've worked together in the past, so we have an understanding of how we try to push boundaries as much as we often can. Talking about pushing boundaries, Matt, there's a question that we have here by Chris Stretfield, and this reminds me of the very first project that you and I and some of the others within the Cubico business globally worked on. And Chris asks, how do you take into account local, jurisdictional, or cultural issues that will arise?
Yeah, that's a really good question. And it's a very common question that we get as well. So when you look at the stage gate process, it looks like a very rigid, if you like, it's a very rigid process to work with. You know, what do I need to get through this gate? And you've got all these very precise criteria. And what I would say is, and what we found in Cubico, is that you need to start with that framework, and you need to have a very clear idea of what that framework is needing, and what is the overall approach and intent, if you like, of each and every stage gate. So there are some things that are non-negotiable. But of course, when you get into applying these things per market, or even actually per project, because a 250 megawatt project has very different needs to a 20 megawatt PV project, you can always make exceptions, or you can always make deviations that are appropriate to that market, that are appropriate to that culture, or appropriate to this site or the technology. The point is, you've got your point of reference, you've got your very clear structure and framework that you're working to, and so you say, okay, in this situation, in this context, I think it's appropriate to move this activity from this gate into the next gate, and this is why I would do that. And so I would say you can make these exceptions, but always understand why you're doing it, what's the rationale, and you can make that part of the process. So as I move through this gate, I want to propose that actually at the next gate, I won't be bringing you this, but I will be bringing you that instead.
Absolutely. Well, that's very, very interesting and logical way of dealing with it. Often when talking about jurisdictional and cultural issues, they don't often tend to lend themselves to logic in some instances, because ultimately you're just dealing with the way a group of people behave, or what a local regulatory or grid connection requirement might be, for example. And indeed, when you start thinking about the relevance of Chris's question, it pertains particularly to the bringing together of a number of contractors and subcontractors to deliver these projects together with a project management team or an EPC contractor. And if you do not necessarily take your time to evaluate whether we are putting together a harmonious group of a group of people who have a similar cultural background, or who understand the jurisdictional needs in the same way, then that could often give rise to a significant breakdown in project management, which could then set back even the best developed project. So understanding jurisdictional and cultural issues are particularly important. And in our view and in our experience, this often comes into play right at the feasibility stage, when you're beginning to understand what jurisdiction you're going to develop in, what is the availability of the supply chain within those countries, where are you going to be importing the supply chain from, if that is going to be the case, and indeed what potential issues that might create on the ground in terms of whether these different cultures will come together easily, or whether there needs to be lots of front-end work done to bring about harmonization before we move into proper execution. So, Chris, thank you very much for that question. Grant Foley asks a question, Matt, and he says, he asks, how do you build flexibility into projects to account for consenting or permitting delays that change routes to market or alter available technology?
Yeah, well, I think by nature of project management, you have to be very flexible, and so you are you're constantly taking feedback from, I talked about this wide team at the beginning. So you're constantly taking feedback from whether it's your internal team or whether it's the external advisors. And yes, things are changing all of the time. It's one of the challenges of development that, from 1 year to the next, you might have a completely different permitting regime in place. So you have to be flexible. I would say if you start each stage gate with a plan and recognize that plan may need to change, then you can certainly course correct within the gate. I think the key discipline we're talking about here is that by the time you get to the end of the gate, if you have had to course correct, you've understood why. You should be given a clear budget and mandate at the beginning of each gate. And if things change too much, then under a good project management principles, you should be going back to the project sponsor and saying, look, I think the scope of this project has changed, or maybe the terms of the project charter need to change because, I don't know, I thought I could achieve a 45 megawatt PV project here, but actually it can only be 25 megawatts under the new scheme. I mean, equally, you have the same issue with technological improvements as well. So, in the PV example again, we have bifacial modules which are increasingly popular here. You may start off with a layout that was designed for single-facing modules, but by the time you want to build your project, you actually want to space the rows out a little bit more to account for that. So you need to try and build that flexibility in. I think the stage gate model allows you to do that, but it's really down to the project manager to identify where that flexibility is required for any given project and argue for it at each of those stage gate points.
Brilliant. That's excellent. Thank you very much, Matt. And how timely is this question right now, given the fact that there are so many changes taking place, at least within the renewable onshore market? Well, we expect there to be these changes that take place, and we know how quickly things are changing and how poorly the government's actually communicating. So yes, making time available, ensuring that we do have contingencies in place for these changes to consenting or permitting is quite important. So thank you very much, Grant. That's an excellent question. Halida asks a question which is something that is very relevant to the work that we do to equip organizations to become smarter and more intelligent. And what Halida asks is, how early should asset managers become involved in the stage gate process, and how could their input help project development?
That's a great question, and in many ways it's a very easy question to answer because the answer is, in my mind, is very early. So I think the asset managers should be involved even at feasibility. I mean, I will ask a question of an asset manager in the feasibility stages. Do you think this project is feasible? Do you think we could be building this project? And it's great to get a view from the asset management organization as to what an ultimate project on this site that might look like this would be to operate. And often you get a very blunt answer, and it might not be the one you want to hear, but it's something that you should be looking for and looking to hear, right from the very early stages. So I would say very early. It doesn't need to be long and complex, but just the idea that the asset management team believes that this project would be a project that is not going to cause them too many problems is a good sign. If they start to fluster at the feasibility or early development stages, then you should be asking questions of yourself and really trying to make sure that either the risks or the costs or the concerns that they've got can actually be adequately addressed through that process. So it's, the feedback is a gift in that situation, and hopefully you can address those concerns through the process.
Yeah, absolutely. I mean, this is so critical, having a real life appreciation of what the common and as well as perhaps unknowns on projects likely to be upfront allows you to accommodate for them. So that's quite important. And I know that we do have some asset managers on the call today, so I can almost imagine them nodding their heads as we mention this. It'll be interesting, asset managers, whether your development teams do involve you as early as possible in the development phase or not. So we have 3 minutes to go, and I just wanted to share a few concluding thoughts. And if you do have any further questions, please feel free to ask. One of the challenges that we often tend to find is when we talk about front-end loaded decision making, and when we talk about front-end loading, one of the key indicators of successful project development and execution. So bear with me. I'm just being told that I've missed a question on here, so just bear with me. Sorry, I'm just going to look at this Q&A again. Aha, there we go. Okay, so we've got Chris asking us another question. How early do you take into account co-location opportunities and risks? Is your approach same or different if we add new renewable assets to an existing site? Do you want to pick that one up?
Yeah, sure. Yeah, that's another timely question as well. I think that's a lot of people thinking in those terms. Yeah, we try and consider that as early as we can. I think in this day and age, you've always got to consider that right from the very off. And if you're looking at site feasibility, then you're considering, is there grid capacity available in the area? The minute you put a grid application in, you're typically asking for it to be, whether it's just export or whether you're going to get import-export on it. I'm sure most people these days are asking that question right up front with the grid application, which I think is appropriate. So that will actually shape your project. If you've got a certain amount of export only, then that probably tells you what your projects can achieve, and grid is a key determinant there. In terms of looking at projects to, if you like, retrofit with storage, I think that's almost an entirely other webinar. But yeah, certainly something that we are looking at and have looked at. But again, I would start with grid, which in fact is what we have done. We've identified opportunities, but in many cases, grid is the constraint on a project that's already been built.
Yeah, absolutely. Well, I'm going to skip one of the questions that I was busy teeing up. I'm just looking at the time, so I'm going to conclude. And the first thing I'm going to be saying is thank you very much to Matt for having taken the time to pen down his thoughts and prepare a deck and work through the logic that belay his story today. And the information that you have shared has been incredibly valuable, and we very much appreciate the effort that you've put in, Matt. So to all of you who have been on the call today, thank you too. Hopefully you have all found that this hour that you've spent with us has been valuable. You can tell us about that on the poll that appears on the screen in front of you. So do keep your eyes peeled for the announcement of our next session, where we'll bring to you more ideas about innovative management practices and achievements within forward-thinking renewable organizations from around the world. And if you'd like to know more about front-end loaded decision-making, why not check out our renewable programs on ARMSA Academy, where we delve into this as well as so many other aspects of front-end loaded decision-making in terms of how it could enable you to drive safe and enhanced performance whilst reducing curtailment. So thank you all for your time today. Be safe, be smart, and be effective.